Hello everybody, welcome into another lesson. So today we are going to talk about evaluating polynomial functions. There are two methods for evaluating them. One is called direct substitution, which everyone should be familiar with. The first method is here you have some function f of x, and you're given a certain value, f of 2 in this case, where you evaluate the function at x equals 2. You got f of x equals 5x to the third plus 4x squared plus 8x plus 1. I think everyone here has a pretty good grasp on how to do it, but let's just review it real quick. I'll just take that 2 and I'll put that in for the x. So f of 2 is going to equal 5 times that 2 to the third power plus 4 times 2 to the second power plus 8 times 2 plus 1. Alright? So now you just do some simple order of operations. 5 times what is 2 to the third? That's 8. Plus 4 times what is 2 to the second? Well, that's 4. Plus 8 times 2 plus 1. Alright, so what's 5 times 8? That's 40. Plus 4 times 4 is 16. Plus 8 times 2, that's another 16. Then plus 1. So this would be 73. So the answer you should get, f of 2 would equal 73. So I believe everyone's familiar with direct substitution. That's the method we've been working with all the way since pre-algebra and algebra 1, direct substitution. Now, the second method is what's called synthetic substitution, which actually in some cases can be easier to deal with. I will show you now synthetic substitution, which will be the main focus of this lesson. So let's see here. Synthetic. So you have synthetic substitution. We can evaluate the same function. We should get the same exact answer as with direct substitution. So how you're going to approach that is set yourself up a little table here. Now the idea is you're going to take the coefficients of your variables in descending order. So start with your highest variable, the 5x to the third, the coefficient's 5. You're only going to write the coefficients. You're not going to write the variables. Then go to your x squared, that's your next one, the coefficient's 4. Then go to your x to the first term next, the coefficient is 8. Then go to your constant term, which is 1. What you're going to do then on this side of the table, up higher in it, on the right side of the table, up higher, you'll write all your coefficients of the variables and then the constant term. To the left side up higher, you'll write, where it says f of 2, you'll write that too. This is called synthetic substitution. So here's how you do it then. So that 2, from the f of 2, you put to the left side. So first thing you have to do is you're going to bring down that 5 up from up here. So you'll have 5. Next, you're going to take 2 times 5. What is 2 times 5? That's 10. You'll put that right below your 4. So then what you're going to do next is you'll take that 4 plus 10. What do you get 4 plus 10? That's 14. Alright, now, what is 2 times 14? Yeah, 2 times 14. You'll take that next. That's 28. Then now you'll take 8 plus 28, which is 36. And then what is 2 times 36? That's 72. And then 1 plus 72 is 73. Alright, well, what you're going to do again, so once you get your coefficients and the value for what you're evaluating the function at all set up, you bring down your first number from lower, you multiply by the first number, then you'll add it to the second number, and you'll get your new number, then multiply your function value at 2, multiply 2 times that 14, add that to the 8 plus 28, you'll get 36. Then 2 times 36 gives you 72. Add that to the 1, you get 73. This also is known as synthetic division, which we will get into synthetic division more on how to find factors of polynomials and find zeros of polynomial functions. But for now, we'll just call this synthetic substitution. The idea is whatever number you get on the far right is the function value. So that number 73, that's the value of the function. And that saves you a bunch of having to use exponents in order of operations. That's the idea of synthetic substitution. So that number you get on the far right is going to be the value of the function at that point. And I do have more examples here. Alright, so what if we have f of x is equal to negative 3x to the third plus 7x squared minus 4x plus 8, and this time they want us to evaluate f of 3. So we're going to evaluate f of 3. So go ahead, we're going to use synthetic substitution. So again, set yourself up a little table here, and then up top in this table on the right side, take all your coefficients in descending order. So start with your x cubed. For f of x equals negative 3x cubed plus 7x squared minus 4x plus 8. So that x cubed term has a coefficient of negative 3. Then your x squared term has a coefficient of positive 7. Your x to the first term has a coefficient of negative 4. Then your constant term is positive 8. So you've got all your coefficients set up. Now take the value of x that they want you to evaluate the function for, put that in the top left side of the table. Alright, now you've got it set up, we can proceed to synthetic substitution. So you bring down that negative 3 from above, you'll bring it down below the table. Now take 3 times negative 3, what is that? That's negative 9. You'll put that right below the 7. What's 7 plus negative 9? That's going to be negative 2. Alright, so then what's 3 times negative 2? That's negative 6. Then what's negative 4 plus negative 6? That gives you negative 10. What's 3 times negative 10? That's negative 30. Alright, then last, what is 8 plus negative 30? That would be negative 22. So you get a value, the very last number you get on the right is negative 22. So that would be the value of the function. So f of 3 would equal negative 22. This saves you a lot of having to deal with exponents and deal with a lot of order of operations. This is actually a quicker way to evaluate functions, is this synthetic substitution. And this is also going to tie into something called the remainder and factor theorems. Not in this lesson, but in future lessons. We'll have the remainder and the factor theorems, which go heavily based off of this synthetic substitution / synthetic division. Alright, what's next here? I should probably establish what the new function is, right? Let's see, f of x equals x to the third plus 3x squared plus 6x minus 11. They want us to evaluate this function at f of negative 5. When x is negative 5, so we'll take f of negative 5. That's what we're going to evaluate. So f of x equals x to the third plus 3x squared plus 6x minus 11. They want you to evaluate the function when x is 5, so f of negative 5. So go ahead take your table. In the top right of the table, just take the coefficients of the variables in the constant term. So the coefficient on the x to the third is 1. The coefficient on the x squared is 3. Coefficient on the x to the first is 6. And then your constant term is negative 11. So now we've got all those coefficients in the constant term. In the top left of the table, you'll take the value of x that you're evaluating the function at, which in this case would be negative 5. Alright, so now that we've got all that set up, bring down that first number to the left from the table. That'll be the 1. Bring down your 1. Actually, here, I'm going to write in a different color since we're working out the problem. So yeah, bring down your 1. Now what is negative 5 times 1? That's going to give you negative 5. Now, what's 3 minus 5? That's negative 2. What's negative 5 times negative 2? That's positive 10. All right, so what's 6 plus 10? That's going to be 16. What's negative 5 times 16? That'd be negative 80. Now, negative 11 plus negative 80 gives you negative 91. So that far right number you get here is that negative 91. That's what f of negative 5 is. So f of negative 5 would be equal to negative 91. Because if you did direct substitution, you'd put negative 5 in each of these, and you'd have to deal with all your exponents and multiplication and then doing the final steps. And it actually takes longer that way. So direct substitution's actually synthetic substitution's a very nice method to use. Let's do 3 more. Good one. F of x equals negative x to the 4th. So we have negative x to the 4th plus x to the 3rd. Really good. Minus x plus 1. And they want us to evaluate this function at negative 3. When x equals negative 3, so we're going to find f of negative 3. So we have f of x equals negative x to the 4th plus x to the 3rd minus x plus 1. Alright, so let's go ahead here. Let's set up our table again for the synthetic substitution. So start with the highest variable, your leading coefficient, which would be negative 1 in this case. That's the coefficient on the x to the 4th. Your x to the 3rd has a coefficient of positive 1. Now notice, you have no x squared term. If you have a missing power in between one power to another, it's 0. The coefficient would be 0. So the coefficient on x squared is 0. And then the coefficient on the x to the first term is going to be negative 1. And then you have your constant term of 1. So now that you've set that up, on the top left, you'll take the value of x that you're evaluating the function at, which would be at negative 3. Alright, so we've got it all set up now. Let's go ahead and begin. So bring down that negative 1 from up top. What is negative 3 times negative 1? That's positive 3, right? 1 plus 3 is going to be 4. Now, what's negative 3 times 4? Well, that's negative 12. 0 plus negative 12 is negative 12. So, all right, so negative 3 times negative 12 is what? That's positive 36. Negative 1 plus 36, that's going to be positive 35. And then you have negative 3 times 35, that would be negative 105. 1 plus negative 105, that's negative 104. So that far right value you get down here, that negative 104, that's the value of the function for f of negative 3. So f of negative 3 is going to equal negative 104. That's exactly what f of negative 3 would equal, is negative 104. I got 2 more. I think Personally, I would rather use synthetic substitution to do this than I would direct substitution. Alright, let's see. 2x to the fourth. So f of x equals 2x to the fourth plus x to the third minus 3x squared plus 5x. And you're going to evaluate this when x is -1, so we're going to evaluate f of -1. So f of x equals 2x to the fourth plus x to the third minus 3x squared plus 5x. They want you to find the value of the function when x equals 1, so we'll take f of -1. So go ahead and set up your table for the synthetic substitution. Now start with your leading coefficient. On the x to the fourth term, you have a 2. The x to the third term has a coefficient of 1. The x to the second term has a coefficient of -3. The x to the first term has a coefficient of 5. Notice we have no constant term. We don't have a constant term whatsoever. Well, if you have no constant term in your function, then the constant term is 0. You still have to account for a constant term, so that's going to be 0 at the top here. And then we'll take the value of x that we're trying to find the value of the function for. We'll put the -1 over here. So now we have this all set up. Bring down that 2 from the top. Now take -1 times 2. What's -1 times 2? Well, that'd just be -2, right? What is 1 plus -2? That gives you -1. What is -1 times -1? Well, that's +1. Now, -3 plus 1, that gives you -2. What is -1 times -2? That's +2. What's 5 plus 2? That's going to be 7. -1 times 7 would give you -7. And then 0 plus -7 gives you -7. So that's why we have to account for the constant value. So that far right number you get is the -7. So that means f of -1 is going to be equal to -7. So f of -1 is equal to -7 by synthetic substitution. I got just one more and we're done for the day. Now this one, oh, good one. So let's see, we have 3x to the fifth. So we have 3x to the fifth power minus 2x squared plus x. Yep. So we have f of x equals 3x to the fifth minus 2x squared plus x. And then they want you to evaluate the function when x equals 2. So we'll take f of 2. So we're going to evaluate the function when x equals 2. So go ahead, let's set up our synthetic substitution table here. So now start with the highest power, the fifth power, the leading coefficient, which is 3. Now notice you have no x to the fourth term, so the coefficient on the x to the fourth term is 0. You also have no x to the third term, so the coefficient on x to the third is also 0. Now you have an x squared term, the coefficient on that is -2. You have an x to the first term, the coefficient on that is 1. And you have no constant term, so by default your constant term slot would be a 0. So then, once you've set all the coefficients and stuff up, you're going to take that value of x for what you're evaluating the function for. You'll put the 2 over here. All right, now you're all set. We can begin to do the synthetic substitution. So, bring down your 3. All right, so what's 2 times 3? That's going to be 6. 0 plus 6 is 6. Now what's 2 times 6? That's going to be 12. 0 plus 12 is going to be 12. What's 2 times 12? Well, that's 24. Negative 2 plus 24 is what? Positive 22. What's 2 times 22? Well, that's 44. What's 1 plus 44? That's going to be 45. All right, what's 2 times 45? That's 90. So if you take 0 plus 90, you get 90. And that's the far right number. That's as far as we can go. So that 90 is the value of the function when f of x is f of 2. When you put in 2 for the x, you get f of 2 is equal to 90. That would be the value of f of 2. It would be equal to 90. So that's it for this lesson. Next lesson, we are going to start graphing polynomial functions. We're going to learn not only how to graph them and what the typical curves look like for certain polynomial functions, we're going to discuss what's called the end behavior of these polynomial function graphs. So I hope everyone has a great night. Take care.